Hello friends, after completing the basic lecture of fluid dynamics, now we are in a position to study the Eulers equation of motion. So in Eulers equation of motion, the two types of force are mainly taken into consideration. One is gravitational force and another is pressure force during the motion of the fluid. And this equation is derived by considering the motion of fluid element along a streamline. So, and the assumption here that is taken into consideration that the motion is streamline and there is no turbulence motion, and flow is parallel and along a straight line. So before we'll start, what is how we can calculate the equation of Eulers motion, and let's have a look on the diagram. You can see here from this for deriving the Eulers equation of motion, we have to take the fluid element in cylindrical form. So cylindrical form of fluid element is taken into consideration for deriving the Eulers equation of motion. You can see here that this is the fluid element in cylindrical form, and here it is the this is the inlet and this is the outlet, and at one cross section, and this there is, suppose the pressure exerted on this area dA of this cross section area is P, and the pressure force will be PdA. And let's have a look on the another section. The pressure is opposite to the pressure at this section, and so this pressure force will be equal to P plus dou P by dou S into ds into d, according to Taylor's series. The pressure here is P, then the pressure at this point will be equal, at the other section will be equal to P plus d dou P by dou S into ds, because we are measuring the pressure or where the flow is along the line, along the S line. So this direction is considered as the S direction that I have mentioned here, and this length is considered as the length of the cylinder is ds. So we are considering the motion is along the S direction, not X direction, not Y direction, but it is in S direction. So that is why the pressure is varying here with respect to S. So that is why it is, according to Taylor's series, the pressure at this section will be P plus dou P by dou S into ds, and when it is multiplied by dA, that will be overall pressure force at this section, but it will be opposite to this pressure force at this section, because it is in this force will be opposite because pressure is already in opposite direction. And suppose theta is the angle which the weight of the fluid element is in this direction, and as this weight is equal to rho g dA ds, because as you know, you can see here weight is equal to mg, that is mass into gravity. So m is mass, will be further equal to density into volume. So density keep it as it is, and g keep it as it is, and the volume will be equal to dA into ds. So the volume of the fluid element in the cylinder will be equal to dA, that is area of cross section, into this length ds. Okay, so this is the weight of this fluid element, and it will be acting vertically downwards along this direction, and that this weight will be the direction of the actual direction of the weight. So this direction of weight is inclined at an angle of theta with respect to the direction of the pressure, or you can say at this makes the angle theta with the line, this is the line, center line of the cylinder, or you can say with the pressure force. Okay, so if you have, you can see here from this direction of force and this pressure, this can be resolved, this weight can be further resolved as, if suppose this is the weight and this is the suppose this weight will be exist, if the weight will exist here on this point. Okay, if the weight will exist here also, this rho g ds, if this will exist here on this point, then the triangle will be formed here. This will become ds, and this is the direction of weight. Suppose this part represents length dz, and d is ds, this is ds, and this will be like this side of the triangle, and dz, this is this part, and this dz represents the part, this is the length of this weight, this part weight part, and this will be acting along this direction, and this weight can be resolved along the two perpendicular axes, that is along this side and along this side. And this can be, suppose if this is rho g dA ds, it can be resolved like this. Suppose this weight is inclined at angle of theta with this along the ds direction. So the cos part cos this rho dA ds will be resolved as dz the rho g dA ds cos theta along the ds direction. So along the ds direction it will be resolved, it is cos part, and along this perpendicular to this direction it will be as साइन पार्ट, ठीक है. सो जिसके साथ एंगल बनाता है वी टेक cos part of that this force. So that will be, so here it will be two, there will be force along the ds direction, the force, the weight force will be, the weight will be rho g dA ds cos theta, and we have to take we have to deal with this force, and we don't need this force, this is the not into our consideration this type of force, and we have to only take into consideration this type of force. So let us have a look again what will be the four different forces. You can see here I have written here theta is the angle between the direction of flow and the line of action of the weight of the element, and net force on the element in the direction of s, in the direction of s, in this direction the net force on the element will be equal to, suppose if you take this direction as positive and then this direction as negative, then the net force will be equal to this pda along this direction and minus this force, it is opposite to this this force, and also the weight, the component of this weight, one component of weight will be along this direction as I have shown here. This is the pda, this is the opposite to p plus dou p by dou s dA, this is one other force, pressure force, and this weight one part of the weight will be along this direction. So the weight will be also here can be here written here minus, so that is this force minus this force, and the weight this part of the weight along this direction, that will also can be written here as minus rho g dA ds into cos theta. So this is equation first. Also the resultant force on the fluid element in the direction of s must be equal to the mass of the fluid element into the acceleration in that direction. So we can also say that according to Newton's second law of motion, the resultant force on the fluid element in the s direction, that will be equal to mass of the fluid element into its acceleration into s direction. So that will be equal to, it's this rho dAd is already we have measured that this represents the mass of the fluid element, and suppose as represents the acceleration along the x direction, okay. So as as represents along the acceleration along the s direction, so this is multiplied this force and it will give the overall resultant force on the fluid element. So keep it as equation second, okay. So now we have to calculate what is as actually, what is the acceleration along the s direction. So I will write it as here. How can you can calculate this acceleration along s direction? Suppose this is as represents the acceleration along s direction, and it will be equal to it is equal to dv by dt. Okay, so this acceleration along s direction is equal to dv by dt, that is, it represents the rate of change of velocity along the s direction. V is the velocity, but as you know this velocity v is again equal to, it is equal to d s by dt. Okay, so s represents the distance along the s direction, means v is the velocity of the, just so you know, velocity is the rate of change of distance with respect to time, acceleration is the rate of change of velocity with respect to time. So if as is equal to dv by dt, we can write v as ds by dt. So that means v is the function of s and t. Okay, v is the function of s and t. So we can write it, this can be written again here just like this. We can write as as is again equal to, as is equal to this is equal to d dv by ds into ds by dt. Okay, so this can be also written like this. As is equal to dv by ds into ds by dt, because if we this ds will be cancelled and this will be again equal to, so this will be again equal to dv by dt, okay. So we can further write it as ds is equal to and this dv, this ds by dt, it is the rate of change of distance with respect to time along the s direction. I have already written it is, it represents the v, so we can write as, इसके बदले हम v लिखेंगे, we can write as v into dv by ds. Okay, so this is the value of the acceleration along the s direction. So same thing I have shown here, that this as is equal to v into dv by, you can write it as dou v by dou s or dv by ds. Okay, partial you can write in partial or direct differentiation. So this is the equation third. So now if we put this value of as in this equation, first we have to equate these two equations, because equation first also represents here this represents net force on the fluid element in the s direction, and also equation second also represents the net force or resultant force of the fluid element along s direction. So if we, so that means these two equations can be equated, and also first equate and then put the value of as here. So for equate these two equations, so this equation first can be equal to equation second, and put the value of as in this equation, v into dv by ds. So after simplifying this equation, you can find here, and this will be the resultant net equation, and after simplifying this equation and dividing by this on both sides by ds into d. So after simplifying and dividing on both sides, the both sides of the equation by ds by da, the reduced equation will be like this. Yeah, this will be the reduced equation after simplifying and after dividing both sides by d into ds, and again divide on both sides by rho. ठीक है, dividing both sides by rho, that is density on both of this equation. By this equation we get this minus 1 by rho into dou p by dou, this is dou p by dou s or db by ds. Okay, so this is the pressure and this is density, minus g into d cos theta minus is equal to v into dou v by dou s. Okay, we can also write it as 1 by dou into dou p by dou s minus g into, so cos theta you can calculate from the triangle जो already बना है यहाँ पे, the triangle you can see here from the triangle, the cos theta, suppose this is theta, this represents ds and this is dz. Dz is the length along the this weight part and of the triangle, and this is ds, and theta is the angle between these two sides. And you can suppose this is then if this is theta, then this is perpendicular. So if it's base, this is perpendicular, this is hypotenuse. So cos theta will be equal to base divided by hypotenuse. So cos theta will be here, that it is equal to dz by ds. Okay, so from this you can write it as, so you can put the value of cos theta here, minus g into dz by ds from this triangle, and it will be equal to v into ds by dv by ds. Okay, I have written here also that cos theta is equal to dz by ds. Again you can so the eliminate this minus and yeah, multiply this minus on both sides you can, and also this shift this equation to the right or left hand side, so all the terms can be shifted to the left hand side. Then the equation will be equal to 1 by rho into dou p by dou s plus g into dz by ds into v into dv by ds. Okay, so again this equation can be written like this. You can change the partial differentiation into direct differentiation, and you can write this equation as in terms of d also, and also this can be written as dp by rho, and also you can multiply both sides by ds. So multiplying the equation on both sides by ds, so this will be equal to dp by rho plus g into dz plus v into dv. ठीक है, so this is the equation fourth, and this is the Eulers final equation of motion. ठीक है, so this is the Eulers final equation of motion, and it is dou dp by rho plus g dz plus v into dv is equal to 0. Now we can also calculate this Bernoulli's equation that you already studied from this Eulers equation. The Bernoulli's equation can be calculated from the Euler equation, that is equation 4, by integrating this on both sides. So after integrating, take integral of this equation on both sides, that integral dou p by rho plus integral g dz plus integral v dv is equal to, after integrating 0 it will be constant. Okay, because differentiation of constant is equal to, that means integration of this 0 is called to constant. So it is a reverse of the differentiation. So that means since this in Bernoulli's equation you assume that it is a there is a compressible flow. In Bernoulli's equation you are assuming that if the flow is compressible, then rho is equal to constant. So rho को यहाँ पे constant मानना है हमें. Then you can write this as so integral p will be equal to p by rho plus g z plus this it is integration will be v square by 2 is equal to constant. So then it will be equal to further p by, you can write it as multiplying both sides by of the equation by g. So after dividing the equation by g on both sides, this will be equal to p by rho g plus z plus v square by 2g is equal to constant divided by rho will be again equal to constant, because rho is taken here constant. So this is the final Bernoulli's equation that you already studied, and that was the same equation here. This is the potential pressure head plus potential plus kinetic head is equal to constant, where this pressure head, kinetic head and potential. Now assumptions in this case here is that fluid is idle, steady flow, incompressible flow and irrotational flow. So this was all about this Eulers equation of motion, and how we have studied how we have calculated it is this derived part from the fluid element by considering that it is the cylindrical form. And you can also learn it from my note I will send you. So this was all about this, and thank you very much.